Okay, I am somewhat ready.
Hey, can I?
7-4, day 2.
Did I give you the eraser back yesterday?
Yeah, you did.
Can I have a treatment?
Yeah.
Quick, wait, erase. Erase that little black mark too.
Here you go.
Betsy, leave a voicemail.
Sometimes the phone will be like, is your mom there?
I hate when you're trying to flip around to erase something.
You like this.
Okay.
Where do you think where is she?
I don't know, she's leaving.
Bye.
Or...
She missed it.
Okay, you had one like this yesterday, but only one. I'm asking you for the horizontal and vertical component vector magnitude. In other words, that's pretty much just the length on the horizontal and vertical component. And I tell you the magnitude of U is 18.6 and the angle is 123 degrees. So, what we want to do is sketch it. So, which quadrant do we need to sketch it?
Is that gamma?
Yes, I did.
Is that gamma?
So 123 degrees takes me into which quadrant for my vector?
Second.
Second quadrant. So show that rotation of 123 degrees. It's going into that second quadrant. 123 degrees. Here's the vector, U. With the 18.6. Okay, the problem's asking for the horizontal and vertical vectors that were basically added together to get that. So what you're going to do is make a right triangle. Horizontal and vertical vectors. And because it's asking for magnitude, the magnitude is always positive. That's why they give magnitude with the absolute value bars. So we're looking for the absolute value of the horizontal vector and the absolute value of the vertical vector. So don't pay attention to direction here. We want positive values. Okay, there's a right triangle here. Yes. We can't run a program yet because we don't have enough information. We only have two pieces, the 90 and the 18.6. But like Anna said, you can find the angle inside the triangle here by subtracting from 180. So 180 minus the 123 is 57 degrees in here. Okay. Now, we could do SOHCAHTOA because it's a right triangle, but we'd have to do it twice, do cross products. Not hard, but it would take time. And we wrote programs so we don't have to do that. Which program's going to solve this triangle? Angle, side. So I did write this down yesterday, Anna. AAS. And you should try it. You don't just sit there and write down the answers thinking you know how your programs run or thinking you've got a program that runs correctly. So that's the last thing you want to do is just copy down answers, and then when it comes to the test, you've got a calculator with programs that doesn't work. So go ahead, type in your AAS, and then you have to distinguish which one's the horizontal, which one's the vertical, from the three answers that show up. I know how to do it. You've got to know how to do it. So, go ahead, type it in, plug and chug. It'll take you about 5 seconds to type it in and get some answers, but then can you give me the right one? And if you can't, we got some explaining to do. So, somebody want to give me an H? What's the horizontal one? 10.1. And the vertical? 15.6. Agree or disagree? Anybody need assistance getting those? No assistance needed? Moving on. Okay. Number 2. Each problem slightly different than the other one. Two forces this one here, all of the next section, the story problems for the next 3 days, are just like this example here, only there's no story problem here. Two forces act on a point. Okay, that's their way of saying something like, I've got two ropes attached to a crate and we're going to pull the crate. So the two ropes pulling are the forces acting on a point. So two forces act on a point. Find the magnitude of the resultant force. Find the magnitude of the resultant force. So, picture's huge here. Huge. Huge idea. You need the picture to be able to get these. So there's our point, there's our crate. Now I'm gonna, oh, I forgot to tell you the forces, for goodness sake. The forces are 26.7 pounds of force and 32.1 pounds of force, and the angle between the ropes, or between the forces, is 22.5 degrees. Okay, draw a picture of that, then we'll find the resultant force. So it doesn't matter what direction I put my two ropes in, I just know that the angle between them is 22.5. So here's rope 1, 26.7. I have a smallish angle, but a longer force, 32.1. And then the angle between them was 22.5 degrees. Okay, looking for the resultant force. What do we have to do to get a resultant? Yeah, I'm going to add the vectors together. What's the proper way to add vectors together? Head to tail. Are these head to tail? No, they're tail to tail. So when we've got two people pulling, it's not just add their two forces together, because they're losing a little bit of force by putting the angle between them. So to figure out how much force is actually pulling on this crate, we add the vectors. That's the math behind it. So we have to slide the vectors in order to add them. So we can slide the 26.7 down here. Or we could have slid the 32.1 up. Either way, you only have to move one of them. And when I move both, what shape do I make? Parallelogram. Tell me what you know about the angles inside this parallelogram. Opposites are congruent, so 22.5, 22.5. You are correct. What else do you know? Dylan, you said something? They add up to 360. That's true in any quadrilateral. Something more specific about a parallelogram. What's supplementary in them? The consecutive angles are supplementary. Why is that going to be key? Because when I draw in the resultant, which starts here and finishes over here, what happened to my 22.5? It did not get cut in half. I agree it got chopped up, but definitely not in half. These two angles here are not equal to each other. Do I know what they are? No. I can no longer use that 22.5. But Dylan gave us what we needed. We can find the angle up here, this untouched angle, by doing what? 180 minus the 22.5. That's true in any parallelogram, and every time we slide, we make parallelograms. So this angle is 180 minus the 22.5. What does that leave us with? 157.5 degrees. Now you can solve the triangle, because we're trying to find this red vector here. That's the resultant. I'll call it R for resultant in red. But now which program you're running? SAS. So SAS, run the SAS. Both triangles are the same. Remember, because opposite angles are congruent in a parallelograms, the 157.5 is down here also. So and all I wanted was the resultant force, so it's only the side length that comes up that we need. So if you run the program correctly, what are you coming up with?
57.7.
57.7 pounds of force. Any questions or assistance needed on that one? You can get that answer? So, with the two forces acting on a point slide, you always are going to have to do the 180 minus the given angle, because we chopped that one up when we draw our resultant in, so don't use it because it got chopped up. You need the one over here, and then run your stat. Okay. Next. I better start a new paper. Number 3.
Except it just gave me parallel.
5.
That password.
Find the magnitude and direction of the given vector. And I'm going to give you a different notation for the vector. Vector A -4, 6 inside of pointed brackets. So what do you think I'm telling you about the vector here?
Start point, end point.
That's where the end point of the vector is at. It's kind of like an ordered pair, but because it's in the, it is an ordered pair, but because it's in the pointed brackets, I know it's a vector. It's the end point of the vector. So this is in second quadrant again. -4, 6. There's my vector A.
I always start the margin.
Always. Okay, the question is, give the magnitude, that's pretty much the length of the vector.
Distance from.
Nope. And we need the direction. What's the direction again? Direction is an angle measure from where?
East line.
From the east line. So we want to know this length, because that's the magnitude, and we want to know this rotation. I'll call it x degrees. Those are the two questions that it's asking. We can always work with a right triangle when we work with the vectors on the coordinate plane. So if I make my right triangle, because I know that end point, what does that tell me about my right triangle? Oh, yeah.
The X and
The x and the y. I don't care about the negative. This is a triangle, so the side length down here is a 4, and the side length here is a 6. Do we have enough information to run a program?
I. No.
What didn't I put in there that we know?
90.
The 90-degree angle. So, you're going to run a SAS, but then we're going to have to interpret some answers here. Okay, well, the magnitude is easy. That's just the side length that it comes up with. So what is the magnitude of U, or A?
7.2.
7.2. That's the force. Okay, the other two answers it's giving you are the two angle measures here, inside the triangle. Which one of those is going to help me get the angle that I want?
33.
Is it the 33?
Yeah.